Right. Good evening, Buddha. Can you hear me?
Yes, sir. Good evening,
Okay.
sir.
Good evening. So let's start. We I gave you some works. I hope that this is not too much difficult for you. So I will do few, not few. I will do one or two on this one. Like for an example, if you take Fe2O3, sorry, Fe3O4, I have given you the molecular mass can be calculated in this manner: 3 into 56 plus 4 into 16. So you can do the math for this one, right? So if I take sodium carbonate dot NH2O, this one can be calculated like 2 into 23. Sodium is 23. I have given it to you. Plus 1 into 12. Carbon is 12. Plus plus 3 into 16. Plus now here 10 H2O means H2O molecules, there are 10 H2O molecules, right? So you can do this one in two ways. One is calculate the molecular mass for H2O and multiplied by 10. Or you can do, there are 20 hydrogen atoms and 10 oxygen atoms. In this manner, you can calculate accordingly. So I will follow the number of atoms one. So there are 20 hydrogen atoms, which is one, plus there are 10 oxygen atoms like this. So you can calculate the molecular mass for this one. Any questions on this one? Do I need to do more, or is it okay with you? I think this is you have done this one in all levels as well. Am I correct?
Yes, sir.
Okay, good. So any questions? No, right?
Yes.
Any difficulties? Okay, okay, okay. So let's move into the next one. Let's try a one of the important topic. I think you have done this one in all levels as well, but let's refresh the memories and move into the more advanced concepts. Write the topic mole concept. Mole concept. Right. Now, there are numbers are given and those numbers are having names. Numbers are used for the counting purposes. For an example, let's say number is a symbol. I think in mathematics class, I think you have done this one. So from the history of, it has been used many symbols like Roman numbers, like Hindu Arabic numbers, or likewise. So for a specific count, we are giving a number, and that number has a certain name. They are given with names. Numbers have names, right? This symbol that I have written down in the screen, that is called as 1. So this is the name actually. 1 means name. This is the symbol, that this one is the symbol, right? And also we know this is called as 10. And like this is called as 1000. So this is called as million, right? So 12 zeros. is called as trillion, right? So I have seen that 2027 budget, Sri Lanka budget is around 20 trillion LKR. Sorry, 2 trillion LKR, 2 trillion. So it's a massive budget next year coming up. LKR, right? Not USD. So likewise, these numbers have a name. Now, this number 6.022 into 10 to the power 23, this number is pretty special in chemistry. This number, I told you that number has, some numbers are given names, have been given names. I think all the numbers have names, right? 11, 12, 13, 14, blah, blah, blah. So this number is a very large number. This is trillion number, close to trillion times trillion, right? Sometimes more than that as well. Yeah, close to that one, right? So it's a huge number. In chemistry, this number is special. So this number is given the name mole. So the concept of mole means it's a number, and the mole is the name given for that number. This number is initially invented or discovered or introduced by Avogadro, Emilio Avogadro. Yeah, Emilio Avogadro. So therefore, this number is called as Avogadro number as well. Avogadro number. This number has some notations as well. Sometimes this is denoted by capital L. Sometimes this is denoted by NA, capital NA. Subscript A, capital A. So mole is not like a magic. It is just a number, right? So if you take any parameter, let's say ants, Kumi ants, 6.022 into 10 to the power 23, we can say there are 1 mole of ants. You take pens, 6.022 into 10 to the power 23 pens, we can say 1 mole of pen, right? Now, if I take 1 mole of ants, it means there are 6.022 into 10 to the power 23 ants. One ant has 4 legs. What idea, I don't know. Let's say there are 4 legs. Right? So one ant has 4 legs means 2 ants has 8 legs. 3 ants has 12 legs. 4 ants has 16 legs. So that is 4 times always. So if we take 1 mole of ants, there are 4 moles of ant legs multiplied by 4. Simple theory I'm talking about, right? So we have taken 1 mole of ants. 1 ant has 4 legs. So therefore there will be 4 moles of ant legs in this sample, right? So we can say 4 mole of ant legs. In terms of number, this is 4 into 6.022 into 10 to the power 23 ant legs. Let's say each ant is given by half of banana. Kumi banana, let's say half of banana, right? So for 1 mole of ants, it needs half moles of banana. because we have 1 mole of ants. Each ant is given by half of banana. Then we need half of mole bananas to feed ants. Just a logic I'm talking about, right? So if there are 2 ants, there will be half of bananas. That means 1. Forget about converting fractions into an integer. We can simply say half of moles of bananas are needed to feed ants. So likewise, if you know the count, if you know the number, you can deduce some other numbers based on the mole or based on the defined number. Same can be applied for a mole as well, because mole is just a number. Nothing new. Mole is a number. So why this number is important? If you can remember, the atomic mass unit is being taken as 1/12 of mass of carbon 612 atom. This carbon 612 atom is pretty special one, because if you take carbon 612 exactly 12 grams, carbon 612. If you count the number of atoms of in this sample, it has been found that it has 6.022 into 10 to the power 23 carbon 612 atoms. So if you take 12 grams of exactly 12 grams of carbon 612 sample, there are 1 mole of carbon 612 atoms. So this is why this number is important. This number is important, and this is why carbon 612 is also important, because Avogadro number is defined and derived based on carbon 612. You take exactly 12 grams of carbon 612, it has been found that based on mathematical calculations, there are 6.022 into 10 to the power 23 carbon 612 atoms. That means Avogadro number of atoms. That means, in other words, 1 mole of atoms will be there. Now I am saying, okay, I will take zinc 6.022 into 10 to the power 23 atoms. In other words, I can say there are 1 mole of zinc atoms. Very simple. I'm taking 3.011 into 10 to the power 23 copper atoms. This is 0.5 mole of copper moles or copper atoms. Let's say I'm taking 88024 into 10 to the power 23 nitrogen atoms. So we can say this is exactly 4 mole of nitrogen atoms. So in this way, we can define the mole concept. Mole is just a number. What is the number? Avogadro number 6.022 into 10 to the power 23. Any questions on this?
No.
Okay. So let's write down under this one the mole concept. Each and every number has a name. Let's write down. Each and every number has a name. example මෙන්න මේ සෙට් එක දාගන්න ඔයා මෙහෙම ලියන්න එපා යට රැට දාගන්න නෝට් එක යට රැට දාගන්න
Okay, sir.
okay so on that one let's write down if you take exactly 12 grams of if you take exactly 12 grams of carbon 612 atom sample it was found that this sample has 6.022 into 10 to the power 23 atoms. 6.022 into 10 to the power 23 carbon 612 atoms. Carbon 612 atoms. This number was found by Emilio Avogadro. Avogadro. Therefore, this number is called as Avogadro number. This number is called as Avogadro number. Avogadro number. Next bullet point. If you take any parameter, in this number count, it is called as 1 mole. It is called as 1 mole. Example. 6.022 into 10 to the power 23 pence. 1 mole of pence. 6.022 into 10 to the power 23 ants. 1 mole of ants. 3.011 into 10 to the power 23. Let's say bottles. 0.5 moles of bottles. 1 mole of ants have 4 moles of ant legs. 24.088 into 10 to the power 23 nitrogen atoms. 4 moles of nitrogen atoms. Take this down.
Yes.
Right. Then in the next line, write down 6.022 into 10 to the power 23 equals 1 mole. This is Avogadro number LONA denoted by
Okay, sir.
right. Good. So let's try to do some questions on this one. This is a very simple and very powerful concept, right? Chemistry, some of the concepts are very simple, but they are very powerful, right? So let's do some questions on this one. Right on this one. Now, before that, you need to understand, like, we can say, like, 1 mole of atom, 1 mole of molecules, 1 mole of double atoms. So likewise, uh, any quantity can be defined. So you have to understand mole is a number. That's it, right? So if you say, like, if you take 6.022 into 10 to the power 23 H2O molecules, so this is equal to 1 mole of H2O molecules. So likewise, right? So can you guess and or calculate and tell me, in 1 mole of H2O molecules, hydrogen atoms are there?
Sorry, sir.
My question is, if you take 1 mole of H2O molecules, how many hydrogen atoms are there?
Two times Avogadro constant.
2 times Avogadro constant. Very good. So you can simply say 2 moles. 2 moles of hydrogen atoms, right? අර කුඹියාගේ කතන්දරේ මම එකයි කිව්වේ. කුඹිය මෝල් එකක් ගත්තොත් කුඹි කකුල් මෝල් හතරක් තියෙනවා. So because එකක කුඹි කකුල් හතරයි එක්කෙනෙකුට. So likewise, if you take 1 mole of H2O, there are 2 moles of hydrogen, 1 mole of oxygen. This concept is very powerful. So if you take like 1 mole of C6H12O6, there are 6 moles of carbon, 12 mole of hydrogen, 6 moles of oxygen. Very simple, right? So in this manner, you can count the numbers as well. 6 moles means 6 into 10 to the power, sorry, 6 into 6.022 into 10 to the power 23 Avogadro number. Likewise, right? So let's do some questions on this one. First one. Calculate number of sodium atoms. Calculate number of sodium atoms in 2 mole of sodium. In 2 moles of sodium. Make it හදලා මට ගන්න බලන්න. හරිද පුතා? හදලා ඉවර නම් ඉවරද? මට බලන්න.
Dana Gaman, sir.
හරි. Good. Mole කියලා දාන්න ඕනේ නැහැ. ඉතින් atoms දාන්න. That's a atoms number, right? It's just a number, right? Number 2, second question. This concept has to be understood by doing the questions. Okay? Calculate number of hydrogen atoms. Calculate number of hydrogen atoms in 0.08 moles of hydrogen sample. මම ගණන් දෙක තුනක් දෙන්න එකපාරමට හදලා එවන්න හොඳ. Third one, calculate number of oxygen atoms in 0.05 moles of carbon dioxide sample. Number 4, calculate number of oxygen atoms in 2.5 moles of CuSO4.5H2O sample. Right. මේටික මට කරලා එවන්න බා. Do this and send this to me. Then we can discuss. තුනක් විතර වගේ එක දෙකකට දුන්නා. ගණන් තුනක් ළඟ ලියාගෙන හරි කොහොම හරි කමන්න. ලියනකොට හදලා එවන්න බලන්න. Okay, let me check. Yes, very nice. Good. You understood the concept well. Good. Now we can move forward to the next type of questions. So for CuSO4.5H2O, 2.5 moles, you can do in this manner as well. Number of oxygen atoms in one molecule. So there are 4 atoms from CuSO4, this one. There are 5 atoms from H2O, dot 5H2O. So altogether there are 9 atoms. So we are talking about 2.5 moles. So there are oxygen atoms in 2.5 moles of CuSO4.5H2O. These are very simple theories, like this is 9 into 2.5 into 6.022 into 10 to the power 23. So whenever you see the mole in chemistry, it is Avogadro number, right? Nothing more than that, right? So all the calculations has been done with the concept of moles. Otherwise, if this concept is not there, it's very hard to do the calculations because we are dealing with very large numbers. That's the thing, right? It's the same concept. I'm giving the calculations, but this is also needed. That's why I'm giving number 5. Calculate number of moles of sodium chloride. Calculate number of moles of sodium chloride when 6.022 into 10 to the power 20 NaCl atoms are considered. Number 6.
Sir,
Yes.
calculate the number of moles of
Calculate the number of moles of sodium chloride. Sodium chloride when 6.022 into 10 to the power 20 sodium chloride atoms are considered. Sodium chloride atoms are considered. Next question. Calculate total number of atoms in 2.5 moles of H2SO4. It is asking about atoms, right? Next one, number 7. Calculate carbon dioxide moles when 1.5055 into 10 to the power 24 molecules are considered. Number 8. Calculate below considering 0.2 moles of C6H12O6. Number 1, C6H12O6 molecules. Number 2, total number of atoms. Number 3, total number of oxygen atoms. कर लो मोटे बा Once you're done, just show me the snapshots, and after that we can move into the next section. Right. If you take more time, leave some space to complete this one and send it to me. I need to move into the next section, next one. So this concept is, I think you understood properly. You do these things and send it to me within the day. Okay. Leave some space in the note. Okay. Now write the topic.
I sent it, sir.
Same. Okay, you done. Good. Good. Very good. So you properly understood the concept. Very nice. So let's move into the next section. Write the topic. Relationship between mass and moles. Relationship between mass and moles. Right. Now let's consider carbon, nitrogen, oxygen, and hydrogen. Very simple things, very popular, very common atoms which we find in our chemistry scope. You take exactly the mass of carbon, nitrogen, oxygen, or hydrogen, or any other atom in grams to match with their relative atomic mass. Exactly relative atomic mass in grams, then it has exactly 1 moles. For an example, we know relative atomic mass of carbon is 12. So you take 12 grams of carbon, right? And we know the relative atomic mass of nitrogen is 14. You take exactly 14 grams of nitrogen. Relative atomic mass of oxygen is 16. Exactly 16 grams of oxygen. You are taking in terms of grams, not in kilograms. You take exactly 1 grams of hydrogen. all of these are is 1 mole. So the concept is you take any atom in grams to match with their relative atomic mass. You are taking exactly 1 mole of that atom, right? So what is the concept? The concept is you take grams to match with their relative atomic mass. You are taking exactly 1 mole of that atom. So if this can be applied for relative atomic mass, it can be applied for relative molecular mass as well. So for an example, you take H2O, you take carbon dioxide, you take, let's say for an example, NO2. So you take relative molecular mass in grams, then you are taking exactly 1 mole of that molecule, 1 mole of that compound. So relative molecular mass of H2O is 18. So you take 18 grams. Relative molecular mass of carbon dioxide is 44. You can calculate this one. You know this one, how to calculate the relative molecular mass. That's what we have done in the previous class. Take them in grams. Nitrogen dioxide, nitrogen is 14. This is 32. That is 46 grams. You take exactly to match with the relative molecular mass in grams. You are taking 1 mole. So this concept is very powerful and very popular. So what is the relationship that you take any number of mass in terms of grams, divide it by molecular mass or relative atomic mass if it is an atom. Divide it by molecular mass, you will take the number of moles. So if I expand this one, mass of the sample, it can be atoms, it can be molecules, divide by, if it is atom, relative atomic mass. This is equal to number of moles. If you consider the units, M is measured in grams, N is measured in moles. So therefore, in terms of mathematics, this should be grams per mole. So this is one of the very powerful concept in chemical calculations. This is the relationship between moles and mass. Only item that we need to convert mass into moles or moles into mass is relative atomic mass if it is an atom, it is relative molecular mass if it is a molecule. Moving from beginning, the relationship between mass and moles. You take any atom in terms of their relative atomic mass in grams, you are taking 1 mole of that atom. You take relative molecular mass in grams for in any molecule, that is equal to the 1 mole of that molecule. So how to build the relationship between mass and moles? Mass divided by molecular mass is equal to the moles. So molecular mass of a relative molecular mass or relative atomic mass is measured in grams per mole. Because of this relationship, we can calculate the unit of that one as well, right? So this is very powerful, very nice, very beautiful concept, right? Put a bullet point and write down. When you consider any atom sample, any atom sample in grams to match with its relative atomic mass in grams to match with its relative atomic mass. You are taking 1 mole of that atom. You are taking 1 mole of that atom. Right. Write down this sketch. Only this sketch which is within the blue circle.
Okay, sir.
Next bullet point. When a molecule sample is considered, relative molecular mass in grams, sample, relative molecular mass in grams sample contains exactly 1 mole of that molecule. Exactly 1 mole of that molecule. Things only in the yellow box. Huh? Okay.
Okay, sir.
Right. Next bullet point. Therefore, considering mass and moles, relationship, considering mass and mole relationship කියලා එයාට පොත පාඩු ෆොටෝ එකෙන් සෙට් එක දාලා. Okay or not? Okay.
Okay, sir.
Right. Now we are ready to explore this lesson. Right. Write down example number 1 under this one. Calculate number of moles in 4.6 grams of Na sample. N is 23. Number 2, calculate mass of oxygen sample. Mass of oxygen sample. Mass of oxygen, sorry, mass of oxygen 0.08 mole sample. Number 3, calculate total number of atom moles in 0.18 grams of C6H12O6 sample. Here for the second one, oxygen is 60. For the third one, carbon is 12, hydrogen is 1, hydrogen is 12, oxygen is 16. Right. මේටික ලියාගෙන මට කියන්න. ටික මට ගෙදරදී කරලා යවන්න ඕනේ.
Okay, sir.
Right. So we will stop the class from here for today. So tomorrow 2028 class එකේ past paper discussion එක මම ගන්නවා සහ paper number 1 එකේ ඉඳලා මම කතා කරන්න ගන්නවා. පුතා ඒකලා join වෙන්න class වෙනදායි සිකුරාදා මම කියන එක දෙනවා. ඊට ප්‍රශ්නයක් වුණ නැත්නම් මම හිත තියෙන එක join වෙන්න.
Okay, sir.
ගණන් ටික දාගන්න පුළුවන් අපිට. මොකද මට මත් එක්ක ඒව කරන්න එතනදි තමයි වෙලාව ගන්න. මේක join වෙන්න බැරුණොත් මම recording එක දෙන්නම් but live join වෙන එක හොඳයි. හරි. එහෙනම් පන්තියේ ඉන්න රජුන් පුතේ. හරි. ඒක සම්මයි. good night.